experiment 2. I think someone sent. Yes, correct. 512, it's correct. Okay, here we need to select analog or mixed. My path is this one to store the circuit. Then click on OK. Here we are going to create the new project. So click on create a blank project. Create a blank project. Click on OK. Now we will get the editor. Correct, right? So go to part eval. First we need to place the op-amp 741. So this is the op-amp we need to take. So how many op-amps are required? One op-amp is required. Correct, right? One op-amp is required. Then next, what else we want? We want two resistors. Correct, right? We want two resistors. So go to place part. Registers are present in analog. Click on analog library. Here type R. I got the resistors. Okay, take the resistor. Place two resistor. End mode. So one is horizontal, one is in the vertical mode. So let it be or horizontal. I want to make this is the vertical. So select Control R. Okay. Next, what else I want? I want capacitor. Go to place part. Select eval. Type C. Sorry. Select analog. Type C. Okay, got the capacitor. Select. I think only one capacitor is enough. Escape. Yes, I want to rotate it. Control R. Next, what else required? Guys, those who didn't try, those who didn't get, yes, ma'am, can you send the software link on email? No, ma, on email and all we cannot send it. However, we don't have it's loaded in by card. Once again, download it. Okay. Those who didn't get the output, please listen to me. Next, what else we want? We want power supply. We want power supply. Correct, right? Go to place part. Source. Type VDC. Type VDC. Okay, this is the power supply required. How many required? I think two required. I think two required. One, two. Yes, two required. We got two power supply. I think we need to rotate power supply. Bottom one should be connected to negative. Upper one should be connected to positive. Upper one positive. Rotate. Bottom one to negative. Okay. This also you need to rotate. Next, what else required? Next, we require ground. 1, 2, 3, 4 grounds. I think here one more register is required. Go to place part, analog, R, here one register. Next we require ground. Here go to ground, select source, select 0. Okay. One resistor is here, one ground is here, one ground is here. There is one more. One more to one more here. Okay. Now we got the ground. Now we need to do the connection. Yes, 045 is correct. Directly open it on the Chrome, Maithili. No need to open it in the Moodle. Open it in the Google. By God. Okay. Next. Pin number 2 is connected to one end of the capacitor. Pin number 2 is connected to one end of the capacitor, another end of the capacitor is connected to ground. Next, pin number, what's the pin number? Pin number 4 is connected to negative. Pin number 4 is connected to negative, positive is connected to ground. Okay. Next, one end of the resistor is connected to pin number 2 and another end is connected to pin number 6. From here to here, then from pin number 6 to connected to pin number 6. Okay. Next, pin number 3 is connected to another end of this resistor. So pin number 3 is connected to this resistor. Another end of that resistor is connected to ground. Okay, then I need to rotate this ground. Control R. Okay. Connect R1 another end to ground. Next, this resistor should be connected to one end of this resistor should be connected to this way, another end should be connected to pin number 6. Okay. Then pin number 7 to positive, negative to ground. Pin number 7 to positive, negative to ground. Ground I need to rotate. Control R. Yes. So how many junctions are there? 1, 2, 3. See here. I'll zoom it out. 1, 2, 3. So I think few people didn't get the proper output, right? Just few people got the line. Because of that, if you missed the ground, sorry, if you missed the junction, you won't get the proper output. Okay, next I need to change the value of the component. So what is the capacitor value? 0.1 microfarad. So click on this 0.1 U microfarad U. We cannot give mu, so instead we have to give U. So what is the value of this resistor? It's 1K. It's already default. It's 1K. No need to change. So value of these two resistors are 10K because we are going to take the duty cycle as a 50%. 10 kilo ohm. 10 kilo ohm. Next, what else we need to change? We need to change the power supply value. So what is that? 12 volt, 12 volt. So 12 volt. So 12 volt. Anything to change? Everything is fine now? Guys, those who got the output, you can answer. Circuit is correct? Guys, those who rigged up the circuit and got the answer. Is it correct or anything to change? Yes. So once it is done, save it by pressing Ctrl S. Now you need to create the simulation. How to create simulation? See here. So this is the new first time we are going to simulate. So you have to select the new simulation profile. So click on the new simulation profile, give the name EXP. I have given EXP. Even if you forget the name which you have given earlier, you give the new name. Okay, click on create. So once you click on create, so that simulation profile will be added here. It will get be added in the bottom toolbar. Click on that. So you will get the simulation setting. So here you need to set the runtime and the maximum step size. So what is the maximum step size? Run to time is 4 milliseconds. 4 milliseconds, and maximum step size is 0.01. 0.01 milliseconds. Okay. Now once it is done, this play button will be enabled. Play it. I didn't get anything. Even few people got like this. Why I got like this? I have not placed the probe. So probes are here. Voltage are level markers. So place the probes here. Okay. Control S. Then play once again. Save and play once again. Everyone got like this? Kavya was telling, ma'am, I think so my output is wrong. Why it's wrong, Kavya? Guys, everyone got now? Still you people are facing problem. Rakshit, CM Rakshit, are you there? CM Rakshit, have we got the output? Mamisha, you there? Got the output, Mamisha? Is it Rakshit? Number ending with 364? So what happens here is, okay guys, listen here. Okay, so we have used the exactly 50% of the duty cycle. You can see here, see T on and T off, you can see. T on and T off, you can see both are exactly equal. I think if you remember the last first experiment, we have constructed it for 75%. T on was larger than T off. But here for T on and T off both are same because we read it for exactly 50%. If you change the value of R1 and R2, it will be changed. Now we have used R1 and R2 as the same value, that is 10K. That's the reason we are getting T on and T off for same. See, when the capacitor is getting charged, when capacitor gets charging, so it will change from negative to positive, and when capacitor start discharging, it will change from positive to negative. So this is the how this waveform is changing from negative to positive, positive to negative. See here, so starting it is a constant value, correct, right? Have you observed? Have you people observed it? For some amount of time, the waveform is constant. After some time, the capacitor is going to charge. Starting beginning, The capacitor is not going to charge. After some time it's getting charged. Yes or no? Yes. So what examiner will do here means if show this output, okay, fine. Sometimes what examiner will do, they will ask you people to skip this. This constant value is there, right? They will ask you to skip this part. So what you should do in that case, close that output waveform, go to this simulation setting. Don't click on the first simulation setting. Click on edit simulation setting. Make a note of it. Click on simulation setting. So here you can see skip the initial transient bias point calculation. So it's unchecked. Check it. Click on that. So go to simulation edit setting. In that there is a text box, checkbox with skip the initial transient bias point calculation. Click on that, apply, okay. Now you press on the play button. Now you check your output. What will happen? So that starting constant point will be there, right? That will be skipped. That will be skipped. So while starting is discharging, so it went to negative. Then the capacitor started charging, so it will go to the positive. Again it's discharging, again it will change to negative. Is it clear? Rakshit. Ma'am, what to put in run to time? Run to time 4 milliseconds. Run to time 4 milliseconds. Guys, everyone try this. This is the one thing you can get easily in this lab software part. Because you need to execute 4 experiments, 2 hardware, 2 software. At least you people get the software part of the both experiment, you can think that you can pass it. Even if you won't get the hardware. Okay. So even if you're not getting this, then we will be helpless. At least you should try this. Try to get the output for software. Guys, have you changed this? Those who got the output. Have you tried with that? By checking the text box, checkbox, skipping the transition bias. It is depends on the examiner. Sometimes examiner will ask to skip that. Okay. If you ask, then you have to. Voltage source and induction loop involved. You may break the loop by adding and series resistance. I think connection pa which this 1 or 2 last number connection is not proper. Connection. Check the wire once. I think connection is wrong. Check the wire. Remove the wire and replace the new wire. Remove the wire and place the new wire. I think it might be passed through the voltage power supply. The wire should be connected between the components, one end of the component to another end. The wire should not pass on the component. Is it clear? Any doubts in the second experiment? I think only 30% of the students tried this. I don't know about others. Even the people are not replying also. Ah, yes, 347. It's correct one. So sometimes they will ask, examiner will ask to skip it. If they ask to skip it, you should know how to skip that. Just go to edit simulation setting and click on that checkbox. Okay. Any doubts in this experiment? Guys, any doubts? No, man. Okay. Type your reason and keep ready. Type your reasons and keep ready. One. See, I'm saying afterwards in between connection lost, ma'am. Now we are these, ma'am, personal messages. No, nothing. 1, 2, 3, 4, 5, 6, 7, 8, 8, 8 present, 9 present, 10, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25,